Okay, so moving forward, as some of you tune in, well, on your time, when we are gone, just keep in mind that, yes, you are responsible for this content because Thursday, a lot of you will be gone again, correct? Is it jammed?
Do we not have a quiz today or an exam today?
We do not. Because last week we did have 2 parts, but we had mentioned we are not doing part 1. There might have been one in there sideways or something to that effect. Okay. So as you proceed through not only this curriculum, but could be anyone, whether any of the other classes, whether it's biology, zoology, last hour it was anatomy and physiology. Okay. I always like to point out, what do we know about everything that you see there? Other than, yes, the class that we're in, but what about organic compounds? What is everything you can tell me about that, if any? This does pertain to your everyday life. And one of the things I think it's important to note that this probably will interest you more than that of the general chemistry portion, which is what we had just finished up with last week. Because when it comes to these compounds, okay, I want you to take into account this. This is just some of the known compounds that you could order from this supply company. So, one of the things I like to do with Aldrich here, I'll just open up somewhere towards the back, and we are on page 2483. And as you can see, there's still quite a few more pages to go. So with that, look at the print that you see inside of here. Okay? The rest of you can testify to the rest of the class that this print is actually pretty small. So these are all different types of, some of these compounds are quite complex. We don't get to that type of complexity in here. But with that, if you are talking about an organic compound, it has mainly 2 elements in there. And we made reference to it last chapter. So think of a combustion reaction. What is everything you know about a combustion reaction? Okay? Everything that you had said is accurate. So let's put that to context. Okay? So what we mean by that why do we put a 2 there? Because it's diatomic. What other elements are diatomic? Yeah, any of the gases, column 7, except column 8, which are the noble gases. So in a combustion reaction, what byproducts do we get over here? Now, if you're writing this down, that's fine, but no, this is old news up here. What was one product? Okay. So then, the only thing we're missing is this up here, but we had made reference to, I don't know, if it's not raining this afternoon after you get home from track practice, and the rest of you students who get home from your FFA judging of what, land, chickens, poultry, whatever it is. I just thought of poultry because I think that's one of the examples that I had heard from one of your upper classmates. So, you're out at your grill. Well, maybe you're doing the cooking. What are we cooking with? What fuel source? Okay. So we have talked about organic compounds, but we just never really made reference to them. This is just one of them. All organic compounds have to contain at least these two elements. Okay? That's not always the case because for some of you farmers, okay, the reason we say that it's not always the case is very important compound that, did we talk about this? Just down the road going towards Madison. There's a big plant on the south side of the road, Highway 34. This is a compound called ethanol. Okay? Why would that be important for farmers? Right. It's a source that we use corn for to make this product here. And this product goes into what? You are close, but it's an additive. Just like you finish yogurt, I'm just guessing. Was it yogurt? So an additive to that is, did it taste good? Yep. Well, it would, or else you wouldn't eat it, correct? But why does it taste good? Why do a lot of substances taste good? Like right behind you on your desktop there. Why have those? Because they taste good, right? So what makes it taste good? True, but what ingredient? Sugar, that's right. Sugar is an organic compound. So it's an additive that you place into there, just like ethanol. It's not just straight octane. You put different types of blends in there. Could be or 10% ethanol, sometimes it's 15. But if you are really paying a lower price for gasoline, you're putting this type of ethanol in there. What percentage, do you know? It's one of those things to where you pull up to a larger gas station, probably in Sioux Falls, because they would not have this blend here at, almost said 34 stop, or Classic Corner. They may have it out at Prairie Junction and Crossroads. So it's a really cheap fuel blend, but not many vehicles can run off of this fuel source. Yes, it's ethanol, but what percentage of a blend, do you know? So typically you put 10 to 15% ethanol in your vehicles to burn, but if you really want a cheaper fuel source, what would the percentage of that be? How much higher? A lot, yes. So just shoot out a number. 80. I did not think anyone would jump to it that quickly. 85% is a really cheaper fuel blend that you can run in your vehicles. So you might be paying $1.79, $1.80, $2 a gallon tops, perhaps. So if that fuel is so much cheaper, why not burn that in your vehicles? You don't, their mileage goes down, your power certainly goes down, but there's certain reasons why ethanol is great. There's also certain reasons that maybe it's not so great. But if you are a farmer, it is definitely great because that is just another source for you to send your crops to. Rather than just the elevator, you send it to an ethanol plant. Okay. So we've made reference to these. We just did not realize it. Okay. So another organic compound would be that ethanol. Okay. Another organic compound would be that sugar that you had talked about. Those are all additives or other ingredients. Okay. So organic compounds. Like we just alluded to, they have to have the element carbon in it. So remember that Aldrich book that we held up here. Okay? As you can see, you're not going to get a million different compounds in that book. Okay? So chances are some of these compounds, they're just really not that common, but they certainly do exist. And again, I think with this chapter, it's just an introduction to this. And I think since you're already hearing terms that pertain to you, that perhaps this is a little more interesting. And for those of you who chose to write that down in a notebook that I see right in front of you, you're already about 2 steps ahead of everybody else. And again, if you write this down, great. If you don't, that's fine too. But this just helps me explain this content to you. Okay. So Wednesday, of course, we're all here. Tomorrow, you do not leave until it looks 1:45, looks like. And are there any golfers in here? Okay. You don't know if you're going for sure? Okay. Is that don't know if you're going or because you might not know if you're going because of the weather? Okay. All right. So softball, I don't think, no, it's a home game. No, there is no softball tomorrow. Okay. All right. So we've discussed 2 sources, octane and propane. Where do you suppose those 2 substances come from? Well, you could say, well, the gas station. Well, where does the gas station get octane from? Do we know? Well, yes, natural resources. Are those resources going to run out? Perhaps, but the majority of this, I think, at least when I was growing up, a lot of this crude oil or petroleum was usually from the Middle East, if you want to call it Iran, Iraq, and you'd have these huge tankers that are making their way across the ocean, go into a port, and then offload that crude oil so it could then be processed. Okay? So one of the things that's going to affect you, it's not going to be in my lifetime. It's just not. Okay? I probably won't see this. But as far as transportation is concerned, when you hop in a vehicle, the biggest drive for what type of cars has been happening within the last 5 years. Because what type of vehicle do you drive now? What's the fuel source? I heard it. Gasoline or octane. What's another fuel source? Diesel, okay? And oddly enough, can even large trucks, can they run on propane? Sure. So those are 3 different types of fuels that we get from petroleum. But, like I said, not in my lifetime, but what type of vehicle may you be driving in about 30 years from now? What's an EV? It's an electric vehicle, okay? So one of the things, I don't know how all this is going to play, what I mean by play out, depends if Congress pushes, and I know we're not that we're discussing politics, but this actually can have an impact on yourself. Because if you are driving electrical vehicles, what happens if we don't continue drilling for petroleum? Do you think that's going to have an effect on yourself? Well, let's take a look. Okay, and we'll come back to this in just a moment. So all I had done was just look at a single or simple search here. And what I mean by that is, look at this here. A partial list of products made from petroleum or crude oil. Okay, now some of these, yes, they really don't affect you. Well, football players maybe. There was one that really stuck out in my mind, and that is right here. Okay, cortisone. Okay, now the reason that that does not affect you as individuals, but it might affect your grandparents. Okay, because one of the things, oh, my knee is bothering me, my back is bothering me, I need to go grab a shot. A shot of what? Liquor? No, not liquor, no. Well, that might help, but kind of ease some of the pain. We can't be always serious all the time, but you were right. What did you say? Cortisone shot. Do you possibly know what cortisone is really classified as? It's actually a steroid. You might be telling yourself, whoa, why are some people injecting themselves with steroids? Well, if a doctor approves that, well then certainly you're going to adhere that, because one of the things, it just lowers what's called inflammation. For anyone who's ever been in volleyball, track, cross country, football, basketball, you jump up and your foot turns sideways when you come down. Okay? So one of the things, your body has a natural response to that. All of a sudden, liquid is going to start pooling into that joint. That's what we call inflammation. Okay? Little tiny pockets are just pushing all that, it's called interstitial fluid, into that joint. So what do you do? What's the first thing that you do? You go to the coach's office here and grab what? You're going to grab ice, because what that ice does is it really closes those little channels, so the body that's injured isn't going to start swelling up as fast. Okay? But on the other hand, what this does, this cortisone, is it limits that inflammation as well, because that's usually what happens. I don't get a cortisone shot. Who knows, maybe in about 20 years. I can't speak for all of us, Mrs. Herbert, but
Yeah.
oh, are you speaking from experience? Okay. So it hurts. So does that pain eventually go away and then you start feeling better?
A couple days after.
Okay. And then that lasts for 2 months, 3 months?
Depends on the person. Never worked for me.
And never? Okay. So if we look at some of these other, let's say, other products on here, again, this was just 400 of 6,000. And maybe this list could go on and on and on. Okay? The reason I look at this, car battery cases. Okay? Those cases are probably made of what substance? Starts with a P. Plastics. Okay? So typically, there's different types of substances like this type of plastic that can withstand different even types of acids. Because if we're saying car battery cases, does anyone know what acid is going through the cells of your battery? I know some of you do have dry cell batteries, but some of you shake that. Yes, there's water in there. But there's also a separate type of acid that's in there. It starts with an S. Anybody? Nope, not quite. Sulfuric acid does that. Okay? So What this really is not touching upon is, okay, plastics. It does make reference to them. What about this? Just think, antiseptics, okay? Petroleum jelly. How many of you use Vaseline for, I've seen students here, they'll grab some Vaseline and rather than using chapstick, maybe they put that on their lips for hydration, okay? But one of the things that stuck out in my mind is these two here, okay? Because we get medicine from this petroleum. So if we stop that drilling, we're going to have to find an alternate source for some of these products. Okay? So again, if we start limiting that certain aspects, it's not that we can't. Oh, shoot. Okay? This here. It's not that we would be out of these. It just would be a lot more expensive to get this from an alternate source. You can make a lot of the substances that you need, but if you can get them from, you had said, natural, was it yourself? You can get some of these from natural resources where it's just a lot cheaper. Okay. Okay, then, and we've actually done this, you just didn't realize that we did it, okay? So that table that we're just looking at, that's what this is making reference to right here. A lot of different types of medicines we get from petroleum. It's just a way that chemists have been able to make different types of medications for that. Whether it's cortisone, antihistamines, and antiseptics. Those were three of those that stuck out in my mind. So again, some of this is based off of old news. So where can you tell me, where is this element found? It says it has 4 valence electrons. So therefore, according to our periodic table, or the one that you have, where is carbon found? Which column? The 4th column. Because remember, in S and P block elements, the column that falls into tells you how many valence electrons it has. Okay? It's when we go over some of these examples, that is where I would suggest that you write this down. But it's not one of those, again, we're in high school now, so It's your opportunity to help yourself out. Does everyone have this content that wants it? Okay. So what we mean by that, okay. Well, we'll just work on this over here. The simplest organic compound is that. So if we don't see anything written attaching to this carbon, we can presume that that is which element? Do we remember? Because you perhaps wrote this down as well. Those two mean the same thing. Okay? This is what we call a molecular formula. This is a structural formula. Okay? So what you had done earlier this semester, okay, so if we had to do a dot diagram of this, we know that it's in the fourth column. Now this, you already know how to do this, so it's probably not that big of a deal whether you choose to write this down. So how many more bonds does carbon want to form according to that diagram? Just say that louder. It wants to bond to make 4 bonds here, and it does that. So some of these organic compounds we've done already. Okay, well, what happens if we do this then? Again, you would just do the same thing. We've got 2 carbons, and now we've got 6 hydrogens. Okay, because remember, carbon can bond to itself as well. Oops. This has the dots, so we can put hydrogens here now. So we could keep right on going with a lot of these alkanes, because on that table that you chose to write down in your notebook, it went from methane, which is 1 carbon, all the way up to a 10 carbon compound called what? Decane. Okay? So we can go all the way back and do this as well, because remember, if there's nothing on these dashes or sticks, we just know that it's a hydrogen atom. You don't have to write that in. And we've applied that before, you just didn't realize it. This is the example I always use. Why does sulfur not have a subscript to it? We've got 2 hydrogens, we've got 4 oxygens, but why don't we put a 1 here? I think you probably, but the hoodlums out there, repeat that again, please. Nope, not the charge. How many sulfur atoms are in this compound? So why don't we do that? Why don't we put a 1 there? It's just understood that you do have 1, correct? So it's just understood that these are hydrogen atoms, and we've illustrated that over here. Okay. So again, some of this we've applied at that time, you just didn't realize that. Okay. So we can even do, well, we don't have to reinvent the wheel here, because I'm going to cheat here. I'm going to do C2H5O. Okay? So what that means is, keep in mind, C2, 1, 2, hydrogens. 1, 2, 3, 4, 5. Oops, I did that wrong. 6. There we go. Okay? Because we actually see 6 hydrogens. 1, 2, 3, 4, 5. And you got to count that one. So we can do this. Okay? So how many hydrogens do we see? How many hydrogens are in that diagram? Aren't we supposed to have 6? We're also missing what other element? We haven't done our oxygen yet either. Okay? So we can bond an oxygen atom, and from prior knowledge, what column is oxygen in? So how many valence electrons is that? Okay? So there's 1, 2, 3, 4, 5. There's our 6th one. But that oxygen is still 1 electron short. But we still have not done what other element? Because we're supposed to have 6 hydrogens. I see 1, 2, 3, 4, 5. There's our 6th one. So there's, again, we've been doing this. We just don't need to apply this anymore. You could do that for propane. You could do that for all of these other compounds. Okay, so first row, are we on the bus here so far? Second row, are we on the bus? Third row. Because if we're nodding our head yes, you are, again, you're telling us that you understand, which is great. Okay. Go ahead and get rid of this garbage, right? Say, no, we like doing this stuff. There's got to be one out there. One? Not even one? Oh, you can help me out, Miss Kay. I like doing this.
I do.
See, all right. So there's always one. Okay. Once we get down to here, we'll stop. We'll start with these hydrocarbons tomorrow. And then I just want to put a few more examples up on the board. And you will get to work on your artistic abilities in here. Because some people can do art quite well. And that comes in the form of what we call ring structures. All the way down to here. Does everyone have this content that wants it? See some pencils still moving. Because these two will tie into one another tomorrow when we start talking about what's called isomers. Okay, so what that means is okay, someone pick a number between 4 and 8. Okay, so according to your table, What compound is that called? Say that again. Heptane. I knew it came from that side of the room. Okay. Okay. So, this is a molecular formula. This is the name of the compound. So, what would a structural formula for heptane look like? We did really simple compounds. This is a molecular formula. So what you can do is string these out. Okay. So there's hydrogen atoms on top. There's 7. There's on the bottom. So there's 14. And then here's 15 and 16. These two mean the same thing. And then would you guess, okay, okay, that compound we just wrote down, upper right hand corner. Okay, this is a structural formula, but what is the molecular formula? How many carbons do we see? Okay. How many hydrogens do you see? Okay. So what that means then, we see 2 identical molecular formulas. But notice some of these exist, and the last thing we talked about, some of them exist as straight chains like this. Then they also can exist as what? It said chains, blank chains, and you're getting a little ahead, you're right, but you're getting a little ahead of yourself. What other types of chains? Starts with a B. Branch chains. So what this means is this is branching off of the parent chain. Okay? These do have the same molecular formula, but the structure is totally different. Okay. Remember, I said we get to test our artistic abilities. Okay? So, why do you suppose we would call something like this? Why would we call that cycloheptane? What's true about its shape? Where is the Department of Defense located in this country? The Pentagon. That's right. So, how many shapes does that building have? Or how many sides? It has 5 sides. So what that means then, okay, where these lines intersect are carbon atoms. Okay? So then, if we had to draw a heptagon, okay? In other words, this is what we call a hexagon, okay? And sometimes maybe you'd rather write it like that. Those are both hexagons. So then what happens is, again, your artistic abilities now we've got a heptagon. How do we know? Well, everywhere that these lines intersect is a carbon atom. So here's an intersection. So there's 1, 2, 3, 4, 5, 6, 7. I mean, it's not an equilateral heptagon, but It's a heptagon nonetheless. Okay. I think that's probably a pretty good place to stop, so you have time to process this, because we've been going for quite a while. So we will catch up to you next time.